We will be doing percent of change, or change expressed as a percent. Percent of change is calculated by going original minus new over the original amount. So let's find each percent of increase, and we will round to the nearest percent. So we start out with 60 and 75. 60 is the original amount, 75 is the new amount, because we go from 60 to 75. So we take the 60, we subtract 75, and we put it over 60. Now the thing that we're concerned about is only the absolute value of the change. So we can go 75 minus 60 and we get 15. We're not concerned about it being negative or positive. So it'll be 15 over 60. We divide that and we get 0.25. Move the decimal over 2 places and we get 25%. The second one down here, we went from 88 to 99. We go 88 minus 99 over 88, right, equals 11 over 88. And before we do the division, it's always a good idea, I didn't do it in the previous one, but it's always a good idea to reduce your fraction first, and this can be 1 over 8. You divide 1 by 8 and you get 0.125. Move the decimal over 2 places and you get 12.5%. But the directions say round to the nearest percent, so this will round to 13%. Okay, it's your turn. Pause the video, try numbers 3 and 4, and then come back to me and we'll see how you did. So we went from 135 to 200, and the original amount was 135, which gives us 65 over 135. And when we do the division on this one, by the way, I probably wouldn't reduce this one because it's a little complicated to reduce this one. Just put 65 divided by 135 in your calculator and you get 0.481. Move the decimal over 2 places and you get 48.1%. The instructions are round to the nearest percent, so you put 48%. Next one is 12 to 18. Hopefully you put 12 minus 18 over 12, which gives you 6 over 12, which is 50%. Did you get both of those correct? Did you remember to change them to the nearest percent? I hope that you did. Okay, now we're going to be studying relative error. Relative error is the ratio of the difference of a measured value and an actual value compared to the actual value. Wow, that's a lot. What it means is that you have a measured value that you are working with, you subtract the actual value, and then you divide by the actual value. So you get the difference between your estimated or measured value and what it actually is, and then you divide it by the actual. So it's just seeing how much you're wrong by, and then dividing it and getting a percent. Let's do an example. A decorator estimates that a rectangular rug is 5 by 8. So he said it was 5 by 8. He or she said it was 5 by 8, but the rug is actually 4 by 8. What is the percent error in the estimated area? Well, remember, it's the estimated value minus the actual value over the actual. So that means we're going to have 5 times 8 is 40 minus 32 over 32 equals 8 over 32, which is 1 over 4, and we should remember that this is 25%. So let's go back and look at the formula one more time. It's the measured or estimated value minus the actual value divided by the actual. And so when we came over here, the decorator estimated 5 by 8, but it was actually 4 by 8. So you subtract the 5 by 8, you subtract the 4 by 8 from the 5 by 8, and you divide it by the 4 by 8. I hope that you got that, but I want you to show me that you did. It's your turn. You think the distance between your house and a friend's house is 5.5 miles, but the actual distance is 4.75 miles. What is the percent error? Remember, you take your estimate minus the actual and divide it by the actual. Pause the video, try this, and then get back to me and we'll see how you did. So you think it's 5.5. Your estimate is 5.5. The actual is 4.75. So we put it over the actual, which is 4.75. So that gives us 0.75 over 4.75. And let me do this on the calculator real quick. 0.75 divided by 4.75, and we get 0.157. 0.157. Move the decimal over 2 places to the right, and we get 15.7%. It didn't tell us any directions on how to round or anything like that, so we'll go with 15.7%. You're framing a poster, and measure the length of the poster is 18.5 inches to the nearest half inch. What are the minimum and maximum possible lengths of the poster? Okay, now this is getting familiar with what we're being asked. Whenever you measure something, if you measure it to the nearest meter, that means that you can be off by a half meter below or a half meter above. So if I tell you that something is 6 meters long, then actually it could be 5.5 meters, or it could be up to 6.5 meters. If I tell you something, if I'm dealing with inches, then it can be a half inch this way or a half inch this way. So if I tell you something is 7 inches long, then it really could be 6.5 inches all the way up to 7.5 inches. If I tell you something that is 4.5 feet, then instead of to the whole foot or the whole inch, or the whole meter or the whole inch or the whole foot, I went to a half a foot. So since I went to a half a foot, it could actually be 1/4 below or 1/4 above. If I told you something was 4 3/4, then that means I've measured to the nearest fourth. So I take half of a fourth, and that means it could be 1/8 below, or it could be 1/8 above. I don't know why I put that second arrow there. Alright, so are we getting the idea? Whatever you measure it to, whether it's a whole item, a half item, or a fourth, it can be a half of that bigger or smaller. So what you do is you take half of one in each direction, or you take half of a half in each direction, or you take half of a fourth in each direction, that kind of thing. Okay, so let's try this one that we're working on. Let me erase all this. it tells you that the length of the poster is 18.5 inches. Okay. To the nearest half inch, what are the minimum and maximum possible lengths of the poster? Well, if I went to the nearest half inch, what's half of 0.5? Right, 0.25. So that means it can be 0.25 that way, or it can be 0.25 that way, which means that it can be 18.25 inches all the way up to 18.75 inches. Well, what if I told you that the distance between my house and your house was 5 miles? What would be the maximum and minimum possible distances between our houses? Well, I did it to the whole mile, so that means it could be anywhere from 4.5 miles all the way up to 5.5 miles. Okay, your turn. A student's height is measured as 66 inches to the nearest inch. What are the student's minimum and maximum possible heights? Pause the video, give it your best shot, and then we'll see what you got. Alright, so they measured 66 inches to the nearest inch. So that means we're going to be to the nearest half inch in each direction. So that means it could have been 65, the person could have been 65.5 inches all the way up to 66.5 inches. Okay, the diagram at the right shows the dimensions of a box to the nearest inch. What is the greatest possible percent error in calculating the volume of the gift box? Alright, so if I measured it to the nearest inch, first of all, let's find out what the volume is of this box. Remember, volume is equal to height times length times width. So that means we're going to go 5 times 6 times 12, and we get 360. Is that right? 30 times 12, 360. Alright, so, but remember, it could be 4.5 inches by 5.5 inches by 11.5 inches. Or it could be 5.5 inches by 6.5 inches by 12.5 inches. So those are the possibilities. It could be a half inch less in each category, or it could be a half inch more in each category, length, width, and height. So we multiply 4.5 times 5.5 times 11.5, and we get 284.63. We go 5.5 times 6.5 times 12.5, and we get 446.88. Now to find the error, we go 360 minus 284.63, and we get 76.75.37. And we get 446.88 minus 360, and we get 86.88. Now what we are concerned with is the greatest possible percent error. So the only thing we were concerned about is the greater difference. So we are concerned with the 86.88. So we go 86.88 divided by the 360, and that gives us 0.24, or 24%. So the greatest possible percent error in calculating the volume of this gift box was 24%. Suppose you measure two cubes. Remember, a cube has the same length, width, and height. Okay? A cube has the same length, width, and height. The smaller cube measures 18 centimeters on each side. The larger one measures 45 centimeters on each side. What is the greatest possible percent error of the volume of each cube? Round to the nearest percent. Remember, what you're going to do is find the actual volume of the cube. Then you're going to find the lowest it could be in error or the highest it can be in error, and compare those. Okay, remember what you're going to do is you're going to get the actual volume of the cube, and then you're going to find out what it could possibly be on the lowest end and the highest end. Okay? You're going to do that for the 18 centimeter cube and for the 45 centimeter cube, and you're going to find the greatest possible percent error of each one. Pause the video, give this a try, and then come back and we'll see how you did. Okay, the actual volume is 18 centimeters by 18 centimeters by 18 centimeters, or 5,832 centimeters cubed. Okay, now what could it possibly be on the low end? Well, since it was measured to the nearest centimeter, that means it can be half a centimeter less or half a centimeter more on each side. So that means it could be 17.5 by 17.5 by 17.5, which comes out to 5,359.38 centimeters cubed. Or it could come out to 18.5 times 18.5 times 18.5, which is 6,331.63 centimeters cubed. Now let's find the difference. We go 5832 minus 5359.38, and we get 473 divided by the 5832, which gives us 8%. Then we do 6331.63 minus 5832, and we get 500. We divide it by the actual amount of 5832, and we get 9%. So the greatest possible error here is 9%. Now let's check the other one. It actually is 45 by 45 by 45, and we get 91,125 centimeters cubed. It could be half a centimeter less. It could be 44.5 by 44.5 by 44.5, and we would get 88,121. We subtract the two, we get 3,004, and we divide it by the actual amount. That gives us 3%. We do the same thing over here. It could be 45.5 by 45.5 by 45.5, which would give us 94,196. We subtract those and we get 3,071. Divided by 91,125 gives us 3% also, since we're rounding to the nearest percent. Now what did you notice here? Why use the same measuring unit did not yield the same percent error for the two cubes? Why? Well, the larger your measure, the smaller the percent of error. See, when we had 18 centimeters, it was 9%. When we had 45 centimeters, it was 3%. And if you had 100 centimeters, you could interpolate that it would be less than 3% error on the volume of each cube. And if it was 5 centimeters by 5 centimeters by 5 centimeters, you could interpolate that it would be greater than 9%. You're going to have fun doing this.